Alright, first things first, there are just the answers for the homework, so pause that if you need to right now. And moving on, alright. So, we're going to keep going with this volume stuff. I kind of told you what we were going to do today already. Up until now, when we've revolved something, it's made a nice solid thing, and we can just chop it into discs and calculate the volume. But I told you that's not going to happen anymore. I've already pre-drawn my little graphs here. So, just going to do a couple examples, and you're going to have like 4 homework problems, and that's going to be it. So, this is a graph of y equals x squared, and this is the graph of y equals x. And so we're going to pretend this is going to get revolved around the x-axis, so around there, and it's going to create a solid, and we're going to find the volume. So in order to do that, we have to think what this thing would look like a little bit. So if we revolve it around the x-axis, of course it's going to be like this, kind of something like that, kind of like a funnel with a, whoops, that wasn't very good. Kind of like a funnel with a curved inside. So when we cut our cross sections out, obviously we're not going to cut them this way, because then I can't even think what that would look like. That'd be weird. But if we cut out a cross section this way, they're all going to be shaped, as I told you, like washers of varying thickness. Obviously, if I cut it out of the middle here, this is going to be thicker. If I cut it out of the ends, it's going to be, whoops, you can't even see that. If I cut it out of the middle here, the width of like the, we'll call it metal or whatever, the width of the material is going to be thicker. If I cut it out of the end, this is going to be thinner. And so that's going to change over time. So if we can figure out how to calculate the area of one of those washer-shaped cross sections, we'll be good, and we can integrate and get the volume. So to do that, let's figure out what the area of this washer is. Well, if you remember from geometry, we did areas of circles, and obviously the area of a circle is pi r squared. But when you got a hole in it, what do? Well, you just take the big area, the area of the whole thing, and then you subtract the area of the hole, right? We did that in geometry. So the area of this, we'll say is pi, and we'll call the big circle, or the outside one, we'll call that big R. So that's pi big R squared. And then we got to subtract the area inside, or the area of the hole, which will be pi times, and we'll call that our little r. Makes sense, right? Big radius, little radius. I didn't come up with that myself. When I wrote my own notes, I called it R1 and R2, and then I looked in the book. I was like, oh, big R, small r. That makes a lot more sense. So can't take credit for that one. Anyway, so that's it. And we can actually, to make this look a little simpler, we can factor out that pi. So it's pi times r squared minus r squared. So I factor out the pi. That's the area of that washer. Oops. So now we need to figure out our radii. So the big radius and the small radius, we need to figure out what they're going to be. So we come up to the picture here. And if I'm looking at my picture, my big radius is obviously from here to the outside, right? That's, from the center to the outside. Well, that's pretty easy. Isn't that just x? So my big radius is x. What's my little radius? Well, that's pretty easy also, just from there to that curve. This is actually probably easier than what maybe we did yesterday. So from there to that curve, that's my little radius. That's x squared. So So the little radius is x squared. Well, so now plug that into here. So I'm kind of going in a weird order here. I'm not used to holding the camera anymore. So my area, my washer, my cross section will be pi times my big radius squared, so x squared, minus my little radius squared, which is x squared squared. So in other words, pi times x squared minus x to the fourth. So then my integral for finding the volume will be from 0 to, what's that point of intersection? I don't know. Well, you gotta figure that out, right? Where do those intersect? You could probably do it in your head, or just think about it, but if you can't, you'd have to set them equal. X squared equals x, and then you'd have to solve for x. Alright, so I minus x from both sides, so I have x squared minus x equals 0, and factor out the x. This was poorly planned here. So we got x times x minus 1 equals 0. So x equals 0 and x equals 1. So that point is 1. So we're integrating from 0 to 1. I could have pulled the pi out front. It's probably actually easier, right? Because I'm going to put my area pi times x squared minus x to the fourth dx. And I'm not actually going to do that. I'm just going to set these up. Get you the idea. Could have pulled the pi out front. Whatever. In your homework, you actually have to find the volume, so you got to keep going. But one important thing to point out is when you are doing this area, it's very tempting right here to write area equals pi and then put all this stuff in here and then square the whole thing. But that is not correct. You know, because you're in your head, you're kind of thinking pi r squared, so you do pi times whatever's in here and then square it. Well, not anymore. Because what we're really looking for is pi times big R squared minus pi times little r squared. Factor out the pi, so it's pi times, and inside it's r squared minus r squared. It is not r minus r squared. If you notice the difference, this one is exactly this. This big radius gives me the area of the whole thing, minus this little radius gives me the area of the whole, and I'm left with just the shaded area. This one would give me, if I do r minus r, that gives me this distance right here, the width of my washer, and then I'm squaring that and multiplying by pi, which gives me absolutely nothing, because this is not a circle. It's a washer. It's not a circle. There's a bunch of crap missing from the inside. So that doesn't work. So don't, it's tempting to do that, but it's not correct. Okay, easy enough. It's basically just like what we did before. We're going to do it once more, but now we're going to revolve around the y-axis. I'll go this way. So here's this. So if I revolve it, it's going to kind of, I'm just drawing this for visualization. It's going to kind of look, again, that funnel shape with the it's going to, well, actually the inside now is going to be straight and the outside is going to be more like a bowl with straight insides. I don't know, kind of weird. We know from before this point's 1, and this of course will be -1, and alright, let's go from there. So when we cut our cross sections here, we have to cut this way, right? So that when I'm looking down on it, now there's my washer. Whenever you cut your cross sections this way, your whole thing, your integration, your everything's going to be with respect to y. Whenever you cut them vertically like that, everything's with respect to x. So here now this is all different. So let's figure out the radii, whatever you want to say, of these washers. So if we do that, what's our big radius? It's nice because we revolved around the y-axis. So my big radius is just from here to the outside. Well, that's easy. Isn't that that's the parabola, so that's y equals x squared. So my big radius, do I want to use x squared? The answer is no, I don't want to use x squared, because it's not changing with respect to x. As I move along here, and this gets longer, I mean, having it with respect to x doesn't make sense, because I'm over the, I don't even know how to say it. Like, there's not one thing x equals. Right here I could say, oh, y equals 1, so my length is this. But now when y equals 1.5, oh, now my length changed a little bit. So I need it with respect to y, so remember like yesterday, solve for x, so x equals the square root of y. So really this length right here is the square root of whatever my y value is. So my big radius is the square root of y. My little radius from there to there, well, this one was y equals x, so same thing either way. My little radius is just y, and now we can go from there. So my area of my washer is just pi times square root of y squared minus y squared. That's it. Which is, that's just y, so it's really pi times y minus y squared. If this confuses you, if you're not feeling that, you could write the whole thing out. I mean, you could write, oh, my area equals, the big one is pi times square root of y squared, right? Pi r squared for the big circle, minus pi r squared for the little circle, pi times y squared. And then go, oh, I can factor out a pi, and go from there. So if you're not feeling this, or if you're tempted to square that whole thing, just do that one extra step, I guess. I mean, it's not that big a deal. It's like an extra 5 seconds, just to be safe. So my area then is pi times y minus y squared. So my integral for volume would be from 0 to, I don't know. Remember, it's with respect to y, so I gotta go this way. Or you could think of it as all my discs, or all my washers would be stacked this way, so that's the way I have to integrate. From 0 to, need to know this point. Well, I already know this is 1, so if I just plug 1 in for x, y is 1 also, that's nice. So from 0 to 1 of, I should have pulled the pi out. Volume equals pi from 0 to 1 of y minus y squared dy. Done it. So that's it. Basically the same thing as before. It's just that extra subtracting the hole out of your washer there with that little radius. Hopefully you got last night's homework. I guess I'll find out tomorrow when I see you. And we also need to do this. We're going to do the washerway. Actually, the first thing we will do on Thursday is take this same picture, the y equals x squared and the y equals x, and we will revolve it around like y equals -3. So we'll revolve it around this line, so there's this big huge thing. Or then we'll also like revolve it around x equals 4, and then, you know, do some stuff with that. But it's late and I'm tired, and I don't feel like putting that on this video, and I don't think you feel like listening to it on this video either. So that is all. Here you go. 8.3 numbers. Where did I write that down? 15 through 18. These are, again, all no calculators. I think the hardest part for some of you might be figuring out how to draw the graph. because they just tell you find the volume of solid generated by in the region around the line. So like 15, y equals x, y equals 1, and x equals 0. You actually have to draw a graph. Put the line y equals x, put the line y equals 1, put the line x equals 0. If you put those three on there, you'll create a region. And if you take that region and revolve it around the x-axis, that's what you're finding the volume of. This one's pretty, I picked the easy ones to graph. 15, 16, y equals 2x. If you can't graph that, then yeah, that's just ask someone in, well, I was going to say ask someone in algebra, but given the way this year's gone, don't do that. I don't know what to tell you. I guess you just, I don't know, don't cheat. Think about it. You know slope, y-intercept. I'm talking too much. Have a good day. Oh, look at that. It's only a 16-minute video, so you got 34 minutes to do your homework. Have fun.